Electrical motors and controls. Hello folks, welcome to our lesson on electrical motors and controls. In this comprehensive lecture, we will explore the foundational elements of AC and DC motors, motor starters, and delve into understanding the characteristics and applications of these essential components in the modern industry. This lesson is designed for employees in a company who are seeking to enhance their knowledge about electrical motors and their control systems, suitable for those at a graduate level of understanding. Introduction to electrical motors and controls, for example, AC and DC motors, motor starters. Overview of electrical motors. Electrical motors are devices that convert electrical energy into mechanical energy, enabling a multitude of applications across various industries. There are two primary types of electrical motors: DC direct current motors and AC alternating current motors. Each type has distinct characteristics, advantages, and applications which we will discuss in detail. DC motors. DC motors are powered by direct current and are known for their simplicity and ease of control. These motors are equipped with commutators and brushes. Here are some key characteristics. Speed control. DC motors provide excellent speed control over a wide range, making them suitable for applications requiring precise operations. Torque. They offer high starting torque, which is beneficial in applications like lifts, hoists, and electric trains. Applications of DC motors. Common applications include electric vehicles, industrial machines, battery-powered devices, AC motors. AC motors are driven by alternating current and are the most common type of motor used in industry due to their reliability and efficiency. They have two main types: induction motors and synchronous motors. Maintenance. AC motors generally require less maintenance than DC motors because they lack brushes. Efficiency. High efficiency levels make them ideal for constant speed applications. Applications of AC motors. They find use in pumps and fans, air conditioning systems, home appliances, motor starters. Motor starters are crucial devices used to safely manage the startup and shutdown of motors. They protect motors from overloads and reduce electrical stress during starts by controlling the initial power surge. There are several types of motor starters, including direct online Dole starters, the simplest form suitable for small motors. Star Delta starters, used to reduce the starting current of larger motors. Soft starters provide smooth start and stop operations by controlling the voltage supply to the motor. Understanding motor characteristics and application. Each type of motor has unique characteristics that make it suitable for specific applications. Understanding these characteristics is crucial for selecting the right motor for the task. Torque speed characteristics. This graph helps in understanding how speed varies with load and helps in designing suitable applications. Efficiency determines how effectively the motor converts electrical energy to mechanical energy, affecting operational costs. Power factor, a measure of how effectively the motor uses electricity. Higher values indicate more efficient usage. Applications of electrical motors. Electrical motors have versatile applications depending on the type and characteristics. Industrial automation. Motors play a critical role in automated manufacturing processes, robotics, and material handling systems. Transportation. From railway engines to electric cars, motors are pivotal in providing motion and power. Domestic appliances. They power everyday items such as washing machines, refrigerators, and air conditioners, enhancing convenience and comfort. Here's a summary of electrical motors and controls. Electrical motors. 1. Definition: convert electrical energy into mechanical energy. 2. Types: DC, AC, induction, synchronous, stepper, and servo motors. 3. Characteristics: power rating, speed, torque, efficiency, and voltage. Motor controls. 1. Definition: regulate and manage motor operation. 2. Types: manual, magnetic, and solid-state starters. 3. Control methods on off, speed, direction, and soft start. Motor control components. 1. Contactors, electromagnetic switches that control motor startup. 2. Relays, electromagnetic switches that control motor operation. 3. Timers, devices that control motor operation based on time. 4. Sensors, devices that monitor motor operation and provide feedback. Applications of electrical motors and controls. 1. Industrial automation, motors and controls used in manufacturing processes. 2. Fixed systems, motors and controls used in heating, ventilation, and air conditioning systems. 3. Transportation systems, motors and controls used in electric vehicles and trains. 4. Home appliances, motors and controls used in household appliances. Benefits of electrical motors and controls. 1. Increased efficiency, motors and controls optimize energy consumption. 2. Improved productivity, motors and controls automate processes, reducing manual labor. 3. Enhanced safety, motors and controls provide safety features such as overload protection.
Challenges and limitations. 1. Complexity. Motors and controls require specialized knowledge and skills. 2. Cost. Motors and controls can be expensive, especially for high-performance applications. 3. Maintenance. Motors and controls require regular maintenance to ensure optimal performance. This summary provides an overview of electrical motors and controls, including types, characteristics, control methods, components, applications, benefits, and challenges. Here's a summary of introduction to electrical motors and controls. Overview. Electrical motors convert electrical energy into mechanical energy, while motor controls regulate and manage motor operation. Types of electrical motors. 1. DC motors use direct current DC to generate torque. 2. AC motors use alternating current AC to generate torque. 3. Induction motors, common type of AC motor, uses electromagnetic induction. 4. Synchronous motors, type of AC motor, operates at a fixed speed. Motor components. 1. Stator, stationary part of the motor. 2. Rotor, rotating part of the motor. 3. Windings, coils of wire that carry electrical current. 4. Bearings, support the rotor and reduce friction. Motor starters. 1. Manual starters, require manual operation to start the motor. 2. Magnetic starters, use electromagnets to start the motor. 3. Solid-state starters, use semiconductor devices to start the motor. Motor control methods. 1. On-off control, simplest form of motor control, turns the motor on or off. 2. Speed control, regulates the motor speed. 3. Direction control, reverses the motor direction. 4. Soft start, gradually increases the motor speed to prevent sudden starts. Applications of electrical motors and controls. 1. Industrial automation, motors and controls are used in manufacturing processes. 2. Public systems, motors and controls regulate heating, ventilation, and air conditioning systems. 3. Transportation systems, motors and controls are used in electric vehicles and trains. 4. Home appliances, motors and controls are used in household appliances such as refrigerators and washing machines.
Safety considerations. 1. Electrical shock, ensure proper insulation and grounding. 2. Overheating, monitor motor temperature and ensure proper cooling. 3. Mechanical hazards, ensure proper guarding and safety features. This summary provides an introduction to electrical motors and controls, including types, components, motor starters, control methods, applications, and safety considerations. Here's a summary of overview of electrical motors. Definition. Electrical motors convert electrical energy into mechanical energy using electromagnetic induction to generate torque. Types of electrical motors. 1. DC motors use direct current DC to generate torque. 2. AC motors use alternating current AC to generate torque. 3. Induction motors, common type of AC motor, uses electromagnetic induction. 4. Synchronous motors, type of AC motor, operates at a fixed speed. 5. Stepper motors use electromagnetic pulses to rotate the motor in discrete steps. 6. Servo motors use feedback mechanisms to control motor position and speed. Motor characteristics. 1. Power rating, maximum power output of the motor. 2. Speed, rotational speed of the motor, measured in RPM. 3. Torque, rotational force produced by the motor. 4. Efficiency, ratio of output power to input power. 5. Voltage, operating voltage of the motor. Motor applications. 1. Industrial automation, motors used in manufacturing processes. 2. HVAC systems, motors used in heating, ventilation, and air conditioning systems. 3. Transportation systems, motors used in electric vehicles and trains. 4. Home appliances, motors used in household appliances such as refrigerators and washing machines. Advantages of electrical motors. 1. High efficiency. Electrical motors can achieve high efficiency, reducing energy consumption. 2. Low maintenance. Electrical motors require minimal maintenance, reducing downtime. 3. Flexibility. Electrical motors can be designed to operate in a variety of applications. Disadvantages of electrical motors. 1. Dependence on electricity. Electrical motors require a reliable electrical supply. 2. Heat generation. Electrical motors can generate heat, reducing efficiency and lifespan. 3. Noise. Electrical motors can produce noise, affecting surrounding environments. This summary provides an overview of electrical motors, including types, characteristics, applications, advantages, and disadvantages. In conclusion, understanding electrical motors and their control systems is imperative for leveraging their full potential across diverse fields. This foundational knowledge ensures better decision-making, improved system designs, and enhanced operational efficiency.